All right, guys, so first as we get into section 3.5, I want to give you an introduction to matrices. Maybe some of you have seen these before. So a matrix, basically the definition is a rectangular array of variables, which is kind of a strange definition. So I'm going to give you just an example so you can kind of see the way everything works. So matrices are denoted with a capital letter, so you could see anything capital A through Z marks a matrix, and we usually have these big brackets, and then inside the brackets, all of the information is organized in rows and columns. All right, so big brackets. So basically, we've just got numbers, positive numbers, negative numbers, decimals, fractions, doesn't matter. You can put absolutely anything in these matrices. Okay, so that's an example of a matrix. Like I said, you've got information organized into rows, organized into columns. So if we look this way, rows are measured horizontally like that. So this particular matrix has 3 rows, and this particular matrix has 3 columns. Columns are the vertical ones, 1, 2, 3. Okay, so then when you state the dimensions of a matrix, you always say rows by columns. So this one, for instance, is a 3 by 3 matrix. Okay, and you can have any whole number dimensions that you want. You know, it could be a 4 by 12 matrix. It could be a 1 by 1 matrix, and you could just have one little element on the inside. All right, so that's kind of an introduction to matrices. That is what we are going to be dealing with. So when we flip, this first example in the first video is going to be all about organizing data into a matrix. Because a lot of times when you're dealing with a specific context, every number in the matrix has a purpose. It's organized in such a way that the position actually makes sense to whatever data you're talking about. So in this first example, we've got a girl named Caitlin who's looking at 3 different Iowa universities, and then she's got all of this information. So like I said, it's purposefully organized in a way that makes sense. So we are going to organize the data in a matrix, columns in the order of tuition, room and board, and enrollment. So we're going to be able to set up all of that information and we can see everything. So it said columns, you want to go tuition, room and board, and then enrollment. So if the columns are being organized by the different categories here, that means the rows are going to be organized by the different universities. So we've got Iowa State, we've got University of Iowa, and then we have University of Northern Iowa. Okay, so those are going to organize our rows. So you can see if we put everything into a matrix here, we're going to have all this data. So the tuition for Iowa State is $61.60, room and board $59.58. I'm basically just copying down all of this information here. Okay, and enrollment would be the total number of people in the university. University of Iowa, $62.93 is the tuition. $72.50 is the room and board, and the enrollment is 30,409 students, and the last bit of information here is Northern Iowa. So I'm just taking all the information that's up here and just copying it down into matrix form, and then we're going to do some stuff with it. So if you read through B, C, and D, they're basically going to ask us like, okay, so all these things that we could potentially do with all the elements, would they really have any contextual application here? So part B, it says, find the average of the elements in column 1 and interpret the results. So they're asking us to look in this column right here, and when it says find the average of something, you add them all up and then divide by the total number. So the average, we're going to take 6160 plus 6293 plus 5352, and then we want to divide it by 3. That's how you find the average of anything. So we're going to take these, and I'm just going to go to a calculator page. We add 6160 plus 6293 plus 5352, and that's the grand total, and then when you divide it by 3, we get our average. So 5935 is the average. And then when it says to interpret the results, so this whole column represented the tuition for the different universities, and so the result would be the average tuition for the 3 universities. Okay, so again, you know that that column in particular represented tuition, so when you add them all together, divide by 3, that's going to give us the average tuition. Would adding the elements of the rows provide meaningful data? So if I were to add the tuition plus the room and board plus the enrollments, I'm going to go no on that one, because if we're adding these 3 values together, like adding these 2 together might make sense, because that's going to give you like a total cost that you would have to pay for your first year at that university. But then if you add the enrollment to it, these 2 values represent money and this represents people. So adding the value of money to people really doesn't make any sense. So basically what I just said, you would say, no, this doesn't make any sense because the first 2 columns are dollar amounts and the third are people. So hopefully we can see that adding a dollar amount to a number of people really isn't going to give us any sort of useful data. Okay, and then part D, would adding the elements of the third column provide meaningful data? So if we were to add these together, then yeah, I mean if we were to add enrollment plus enrollment plus enrollment, that would give us the total number of people at these 3 universities. So yes, this gives the total enrollment at the 3 universities. Okay, so hopefully you can see now why using data inside of a matrix would be useful for us. Now we're going to learn in the next video how to do operations with matrices.